All right, let's talk physics. So, in physics, we're measuring stuff all the time, right? The speed of a plane, the weight of an apple. We use what are called physical quantities. But here's the thing, not all quantities are created equal. They actually come in two totally different types. So let's dive in and figure out what makes them so distinct. So to get us started, I've got a question for you. Is 50 meters always the same as 50 meters? I know, it sounds like a trick question, doesn't it? But trust me, by the end of this, you're going to see why the answer can be a big, fat no. Okay, so here's what we've got on tap. First, we'll look at the difference between quantities. Then we'll get into the two main types, scalar and vector. After that, we'll tackle some classic mix-ups, like distance versus displacement, and speed versus velocity. And we'll finish things off with a little challenge to see what you've learned. Sound good? Let's go. All right, first up, let's start with a really big question here. When we measure something, what information do we actually need? Turns out the answer to that simple question is what splits everything in two. I mean, think about it. If you tell me, hey, my school is 2 kilometers away, have you really told me everything I need to know to get there? Probably not, right? Physics gets this, and that's why it splits every single measurable thing into two big families, all based on the kind of information they give us. So let's meet the first family. These are called scalar quantities, and honestly, these are the measurements we use all the time in our daily lives, probably without even thinking about it. The definition is super straightforward. A scalar quantity is something that's completely described by its magnitude, and magnitude is just a fancy word for a number and its unit. That's it. No direction, no extra info needed, just the number. And these examples, they illustrate the point perfectly. I mean, when you step on a scale, it tells you your mass. Let's say 60 kilograms. It doesn't say 60 kilograms down, does it? Or when you measure something with a ruler, it's 10 centimeters long, not 10 centimeters to the right. The number and the unit tell you the whole story. Things like mass, length, time, temperature, they're all classic scalars. Okay, now for the second family. This is the one that gives us a much, much richer picture of the world around us. We're talking about vector quantities. So what's the big deal here? Well, the crucial difference is that for a vector, just the number isn't enough. You also need to know the direction to get the full story. You can almost think of it like a measurement that has an arrow attached to it, pointing the way. And you see these all the time, especially in science class. Like when you push a box, that's a force, right? You're pushing it with a certain amount of strength in a certain direction. Velocity, acceleration, and this really important one we're about to get to called displacement, they're all vectors. They absolutely need that direction part. Okay, let's really put this into practice now. We're going to compare two of the most commonly mixed up terms in, all of physics, distance and displacement. So on one side, you've got distance. That's our scalar. It's just the total ground you covered. It doesn't care about twists and turns. It's just the whole path. Then on the other side, you've got its vector cousin, displacement. Now this one only cares about two things, where you started and where you ended. It's the shortest possible straight line path between those 2 points with a specific direction attached. And you know what? A real-world example makes this whole thing crystal clear. So let's check this out. Imagine we're taking a road trip, driving from Cairo to Tanta. So if you actually follow the road with all its curves and turns, your car's odometer is going to say you traveled 105 kilometers. That's your distance. But what if a bird just flew in a perfectly straight line from where you started in Cairo to where you ended up in Tanta? That bird would only travel 93 kilometers. So your displacement is 93 kilometers to the northwest. See that? Same exact trip, but two completely different numbers, two totally different quantities. All right, let's jump to our next pair and see how this idea builds. We've talked about how far you've gone. Now let's talk about how fast you're going. And you know what? The relationship here is pretty much exactly the same. Speed is the scalar partner in this duo. It's just the number on your speedometer. But velocity? That's the vector. It tells you not only how fast you're going, but also which way. And to make this super clear, let's bring in a real pro at going fast. The cheetah, one of the fastest land animals on the planet. So a cheetah can book it at an incredible 27 meters per second. That's its speed, just a number. But if we want to talk about its velocity, we've got to be more specific. We'd have to say it's running at 27 meters per second to the west. That little extra piece of information, to the west, that's the magic ingredient that turns scalar speed into vector velocity. Okay, so you've seen the definitions, you've seen the examples. Now it's your turn. Time for a little challenge to put all this together. So take a look at this diagram. We've got a person who starts at point A. First, they walk 30 meters north to point B. Then they turn and walk 60 meters east to C. And finally, they head 30 meters south to point D. So the big question is, what's the total distance they traveled and what's their final displacement? Okay, let's break it down. First up, distance. That's the easy one, right? We just add up every single step of the journey. So that's 30 plus 60 plus 30, which gives us a grand total of 120 meters. Simple enough. Now for the tricky one, displacement. For this, we totally ignore the path they took. We just care about the start point, A, and the end point, D. If you draw a straight line between them, what do you get? Well, because of the shape of the path, that line is exactly 60 meters long, and it points directly to the east. So the displacement is 60 meters east. Big difference. So if there's one thing to take away from all this, it's this really simple but powerful idea. In physics, direction can change everything. Knowing how much is only half the story. Knowing which way, that's the real game changer.
And that right there brings us all the way back to that first question I asked you. Now you know why 50 meters isn't always just 50 meters, because walking 50 meters north is a completely different journey than walking 50 meters south. So I'm going to leave you with a final thought to chew on. Where else in your own life does direction completely change the meaning of everything?